Namaste everyone. Hope all of you are well. Actually, in this pandemic situation, as we know all that how to stay safe at home, right? So my humble request to each and every student, please stay at home and stay safe. The most important thing is that you must be safe. If you will be safe, then only you will study, you will go ahead, and you will get success in your life. So the most important thing, stay safe. Now let's come to the point. Today we are going to discuss about the atoms and molecules. It is a class 9 science chapter number 3, that is atoms and molecules. Now question is, what is atoms and molecules? I have already explained in many videos. You can go through my channel. You can just open the playlist of 9th standard science. You will get all the details. But in this video, I am going to cover each and every topic. So first of all, I would like to tell you the main person who had started about the atoms and molecules was Maharshi Kanad. Today we are going to discuss atoms and molecules. Maharshi Kanad, he was the person who had first said that the smallest particle of a matter, which cannot be cut down, which cannot be break down and does not exist in the free state, is called atom. So this theory was specially applicable in the olden days, that really the atom defined which was given by Maharshi Kanad was not live. Maharshi Kanad has continuously tried to divide smaller particles when there was no existence, it was invisible. He named Paramanu. Paramanu. There are two words in Hindi, Paramanu and Anu. Paramanu means atoms and Anu means molecules. So the atoms, if I talk about, remember the word atoms. Atom is the smallest particle of a matter. What is atom? It is the smallest particle of a matter which cannot be cut down, which cannot be break down, which cannot be seen by the naked eyes, which does not exist in the free state, is called atom. For example, hydrogen, lithium, the single atom means not H2. H2 is a molecule. H is an atom. Oxygen, O2 is a molecule. O is an atom. So remember the word what I am saying. Atom is the smallest particle of a matter. Similarly, if I talk about the molecule, this is also the smallest particle of a matter. But what happens? Molecule can exist in the free state. Molecule can exist in the free state. So as I have said you about the atoms and molecules, you must know about it. So definitely I hope that everybody know about the atoms and molecules. Now question is, how small is the atom? What is the shape, what is the size? In the previous chapter, in the structure of atom, you may have learned about the Rutherford's atomic model. In the Rutherford atomic model, you may have seen the size of the atom. Now question is, in the NCERT also it's written. I hope everybody has NCERT textbook at their home. So now question is, how you will understand about this concept, that what is the shape, what is the size of an atom. So in the structure of atom chapter, as I have said you, the structure of atom chapter has given the detail about the shape and size of the atom. And in this shape and size of the atom, it was described that it is 10 to the power minus 8 centimeter. And furtherly it was concluded, when you will go in the 11th standard, that time you will able to know that what is the accurate radius of an atom. Till 9th standard, what we have to study about the atom? It is the smallest particle of a matter which cannot be cut down, which cannot be break down, which cannot be divided into the small particles, which does not exist in the free state, but which take participations in reaction, That is the most important thing to form any compound. To form any compound, they must participate in the reaction. Molecule is also a smallest particle, but it can break down, it can cut down, it exists in the free state. It can be divided into the atoms. So now when the two atoms combine similarly type atoms, the molecule is formed. O2 is a molecule, H2 is a molecule. Got it? So now come to the point. If any atoms react with each other, then the compound is formed. As for example, the word compound is the very two things you can say about the molecule and compound. What is the difference between the molecule and compound? Molecule means one molecule of water also can be H2O, one molecule. And if I talk about H2O is a compound, when the two elements, dissimilar elements, not similar elements, the two similar atoms combine to form a molecule. That is the different molecule. But if I talk about one molecule of water, then water is a compound, that's one molecule of water. That we will discuss in the mole concept also. So here, if I talk about a compound, then remember, when two elements, two different elements, not similar, I'm talking about one more time, two different elements combine to form a compound. As for example, hydrogen and chlorine, hydrochloric acid, HCl is a compound. Sodium and chlorine, sodium chloride is a compound. It is a salt that you may have heard in the acid-base chapter in the 7 or 8 standard. So here you must remember about atom, molecule and compound. Now, just suppose if any atom will react with each other, any element will react with each other. Element plus element is equal to compound. Right? So in the general words, if we talk about the elements, we know as a reactant. What do we know as? Reactant plus reactant is equal to product. When the two elements react with each other, they give a product formation. And this is the whole process is called chemical reaction. What's known as chemical reaction? Remember this word, chemical reaction. The whole process is known as chemical reaction. Now, each and every reaction follows some laws. Means they obey some rules, and that has been divided into the laws of chemical combination. What is known as laws of chemical combination. This thing was provided for any of the reactions. Any chemical reaction has to obey some rules, has to obey some law. So that's why this is called laws of chemical combination. And this was specially given by the father of chemistry, Antoine A. Lavoisier. The father of chemistry, remember the word, father of chemistry, Antoine A. Lavoisier. So, he has given the first law, that was law of conservation of mass. What was that law? Law of conservation of mass. Now question is what? What is law of conservation of mass? He had said the total mass of the reactant must be equal to the mass of product. Total mass of the reactant must be equal to the mass of product. So that he had said in his reaction that if you take any of the chemical reactions, so he had just said that any chemical reaction has to give the accurate mass of the product. So he has said the same thing as the Albert Einstein had said, that energy can neither be created nor be produced nor be destroyed. It can neither be created nor be destroyed. It can just transfer from one body to another. Similarly, he has said mass can neither be created nor be destroyed in a chemical reaction. Mass can neither be created nor be destroyed, he has said. Means there will be no changing of mass in the reactant and product. The same mass will occur. So that was the law of conservation of mass. If I talk about here reactions, so whatever the mass of the reactant will be there, the same mass will be of the product. There are similar some numericals in our NCERT textbook. You have to just remember the word that the mass of the reactant must be equal to the mass of the product. If the two, as just suppose here any reactant mass is given. Just suppose this is 5 gram, this is 20 gram. So what will be the mass of this reactant? Because the total mass of the reactant is equal to total mass of the product. So just 5 plus x is equal to 20. So x will be 20 minus 5, that will be 15. So remember the way that how to calculate the law of conservation of mass. That mass can neither be created nor be destroyed in a chemical reaction. That was given by Antoine A. Lavoisier. This is Lavoisier. Okay. Now, after understanding this concept, there was one more scientist. He has given the law of definite proportion. What he has given? He has given law of definite proportion or law of constant proportion. Law of constant or definite. Definite means fixed proportions. His name was Joseph Proust. What was his name? Joseph Proust. He has given a law that in any chemical reaction, whatever the compounds or whatever the reactants are reacting to form a compound, they will exist in a fixed ratio. Means definite ratio, definite proportion. As for example, if I talk about the water, just suppose water. Either they have reacted with H2 plus O2 and they have given the formation, or H plus OH minus 1. But whenever the water molecule will form, they will have a fixed ratio. If I talk about fixed ratio, the mass of hydrogen 1 into 2 and oxygen, that is 1 into 16. 16 into 1. So here 2 by 16 means 1 by 8. So whenever the water will exist, it will always exist in 1:8 ratio. Means the mass of water will be 1:8 ratio. You must remember this concept, that law of constant proportion or definite proportion. What do this law says? So you must remember this concept. Really, what do this law says? If anybody will ask you, sir, what is the law of constant proportion? What you will say? Can anybody tell me? What you will say the law of constant proportion? I am telling you the law of constant proportion, which was given by Joseph Proust. It states that the elements are always combined in a fixed proportions. It says that elements are always combined in a fixed proportion. That is law of constant or definite proportion. Got it? So here you can say when the hydrogen and oxygen has treated or reacted with each other, he had done the formation of water, and water always exists in the 1:8 ratio. There are still more some of the laws, like law of multiple proportions, that whenever these atoms will exist, if you talk about the 1 molecule, 2 molecule, 3 molecule, later on you will discuss these all the laws in 11th standard. The third law was law of multiple proportion, after then law of reciprocal proportion, after then Avogadro's law. These all the laws we will study in 11th standard in the 5th chapter, that is states of matter, in the 11th standard. But here till this 9th standard, the 2-3 laws are very much important. That is law of conservation of mass, and the second one is law of constant proportion. Third law, Avogadro law, that was the 5th law, which we will discuss in the mole concept topic. And the rest 2 law, reciprocal and multiple law of multiple proportion and law of reciprocal proportion. These are all the law we will discuss on later in the higher standard. Now let's come to the point that what are the next topics. You must remember what are the next topics. As you will not get the topics, you will never remember that what to study, what not to study, right? So the next topic, after understanding the concept of law of conservation of mass, law of definite proportion, you can take many of the example, whatever the concept I have taught you, just go through that. In your lab manual there will be some experiment related that law of conservation of mass follow this concept or not. Got it? Now we are moving towards another thing, that is the new topic of this chapter, after completing this law of chemical combinations or law of definite proportion, if you want to take more details about the law of definite proportion, then you can just write in your notebook that different elements combine to give a pure compound. The ratio between the masses of these elements will always remain same. That was given by Joseph Proust. Got it? So if you want to write, then you can write this concept also in your notebook, and you can just follow the rules and regulation. The most important theory of this whole chapter or the ninth standard main concept is Dalton atomic theory. DAT. Dalton's atomic theory. The most important theory. The first person who has given his theories about the atom was Dalton. You must know he was a British chemist and he has given his concept in 1808. Remember the word 1808. The first concept of atom was given by Dalton. You know Dalton? A British chemist. You can see in our Gujarat there are a lot of chemical companies in which the chemists are working. Similarly, he was a British chemist. He had provided the nature about the atoms, how do atoms exist and how they take participation in the reaction, they can't be break down, they can't be cut down. He used the word atoms. You know atom. Atom is a Greek word. Do you know Greek? Yeah. Greek word, the meaning of atom is the smallest particle. Meaning only it says that it is the smallest particle. So now, after understanding the concept that it is the smallest particle, now tell me about that. Is there any law of chemical combining or chemical reaction? So Dalton had said atom is the smallest particle of a matter which cannot be cut down, which cannot be break down, but it can take participation in reaction. It can take participation in reaction. Their mass, their atoms, the elements mass and mass will never change. Their atoms will never change, but they will participate in the reaction. So there are many observations about this theory, especially related to the atom, that atom is the smallest particle of a matter which cannot be cut down, which cannot be break down, cannot be seen by the naked eyes, does not exist in the free state. Atom participate in the reactions. So this law, as the Dalton has given in his postulates, if you want to write the postulates, then I can give you. So first postulates, all the matter consists of atom and atom is the smallest particle. Second, atoms are indivisible particles. Indivisible particles means you cannot divide further. Atoms can neither be created nor be destroyed. The third point, all the atoms of given elements are having identical mass. As for example, whatever the atoms are present in the sodium atom has their identical mass, identical shape, identical size. Each and every element has their identical atoms. And all the atoms can participate in a chemical reaction. So atoms of different elements have different size. Remember the word, different element will have different size. Don't compare all the atoms as one element has all the atoms in a similar size. Similarly, another atom will have all the atoms their similar size. But if you compare both the elements and atoms shape and size, then it's not equal. So different elements have different shape, different size, different mass, different chemical properties. All the atoms combine in the ratio to a small whole number to form a compound. Whenever the reaction, they will never react in the fraction form. As for example, just suppose I have told you about hydrogen and oxygen. Oxygen valency 1, hydrogen valency. Whenever they will react, H2O, I will tell you this H2O is a whole number compound. Here there is not half, here there is not 0.2, 0.3. It will always exist in a whole number compound. And the most important thing, that atoms participate in a chemical reaction. That is the most important theory, that atoms is only the thing which participate in the chemical reaction. Got it? So the smallest particle of an element is called atoms. All the compounds are made up of atoms, all the mixtures are made up of atoms, all the matters are made up of atoms. Atoms are so small that you cannot see by the naked eyes, you cannot see even by the microscope. For that you have to bring an electron microscope. With the help of that electron microscope you will be able to see these atoms. Now after getting all this concept, we'll move towards the new topic, that what are the things present in an atom, means subatomic particles. What are the things present in atoms, means what are the subatomic particles. So remember, this is an atom. Atoms are spherical in shape. In the atoms, center of the atom is called nucleus. What is called? Nucleus. Here protons are present and neutrons are present. Protons and neutrons. Remember the words. In an atom, the centered part is called nucleus. In that nucleus, neutrons and protons are present. And this is called orbit. The atoms surrounded, means the orbit are the path of electrons where the electrons moves. Got it? What are these? Orbits, remember. So this is an atom shape. This is whole called atom. This is called orbit. It's also called energy cells. What is called? Energy cells. Electrons are present on the orbit. These electrons, these are the electrons, they move just like the earth in the rotation and revolution. Angular momentum is also created and the electrons moves around. So if anybody will ask you what is electron, proton and neutron, electron is a subatomic particle. It is a negatively charged containing particle. Proton is a positively charged containing particle which is present in the nucleus of an atom. Neutrons are the neutral charged particle which is present in the nucleus of an atom. Orbit, a circular path surrounded around the atom is called orbit. And where this electron will found, that are called orbitals. What are they called? Orbitals. If anybody will ask you what is this orbital, where the maximum probability of finding an electron, maximum probability of finding an electron, finding an electron is called orbital. There are 4 types of orbital: S, P, D and F. Remember this word. All the things detail you will listen or you will read in the 11th standard, but here whatever you must know, that the things I am explaining. Got it? So here the maximum probability of finding an electron is called orbitals, as you have seen here. After then, let's go ahead that what we have to study in this chapter. The next topic, as I have told you, that what will be the size of an atom. So generally it was described in meter. So it was around 10 to the power minus 9 meter. That is called 1 nanometer. You know nanometer? 1 nanometer, that is 10 to the power minus. Generally if you read these things, it is approximately 10 to the power minus 10 meter or 10 to the power minus 8 centimeter. But here I am talking about the nanometer. 1 nanometer is equal to 10 to the power minus 9 meter. The smallest size, means if I talk about the hydrogen atom size, the radius of hydrogen is 0.037 nanometer. Means if we convert these things into the nanometer, 1 nanometer is equal to 10 to the power minus 9 meter. So the smallest atom, the first atom, hydrogen, and hydrogen atomic radius is 0.037 nanometer. Got it? And the relative size, if I have talked about the relative size, then you can just compare 10 to the power minus 10 meter. The distance between the nucleus of an atom and the orbit, that is 10 to the power minus relative atomic mass. Just remember the word relative atomic mass is 10 to the power minus 10 meter. The word I have said, just remember this word, 10 to the power minus 10 meter. After understanding the concept of this size of the atom, there are many elements which were represented by the size earlier
in the periodic table. After then, a lot of concept have came. These are all the things we will learn on later. The main important things that you want to learn is the name of the periodic table. Actually, the two main important thing, that is valency, symbol of elements, atomic